Hello everyone, today we'll continue with the generation of the PCG building with adding the roof and the windows inside the frames for all the floors. So first let's do a quick fix from the state that we left the building in the last tutorial. If you haven't watched it, please go back into the PCG playlist and check the part 1 and part 2 for the building. Currently, if you select the blueprint in the level and you move it anywhere into the scene, you will see that the generation of the floors is always done at the center point of the level, so the 0, 0, 0 point in the X, Y, and Z axis, and not at the place that you selected from with the blueprint position. So if you want to place 2 or more buildings, they will spawn on top of each other. So we need to fix that. Go into the PCG building graph, and here where you are doing the point grid for the vertical point grid in the beginning of our main PCG graph, after you copy the attribute that's responsible for saving the floor value inside each point. So after this, let's do a copy points node like we have for copying all the points for a single floor to all the points. Now let's copy all the floors to the place of our blueprint. So let's right click and get actor data. And this actor data, let's change the setting here to get a single point. So if we click with the A key and select the PCG graph that we have, and if we move the blueprint in the level, you'll see the position is updated with the newly saved values. So we need to copy all of our floors at the point where we have our blueprint, and only after that to copy all the points for a single floor for each of these 4 points. So let's click the A key to stop inspecting this node. And now, no matter where you move this blueprint, you will spawn the building properly. There is a problem now that if you move vertically the blueprint, the floor starts to disappear. So this is because we are filtering here the Z position of our generated points from the grid compared to the position of our blueprint. So instead of copying the points here after this copy attribute, let's disconnect those nodes and let's move this before the filtering of our points. And if we connect now everything, we are copying the points after we create the grid at the place of the blueprint. And now we are properly copying them even in the Z direction. So no matter how high your building needs to be on the ground or some other level, you can move it by this blueprint. If I move the blueprint to the 0 location, there is some gap below the building. So to fix this, when we get the actor data, let's do a transform points. For these transform points, let's disconnect and connect with the new node. And for these transform points, let's move into the Z direction 100 units. It's still over a little bit, so 130. This seems to be fine. Okay, so now we are properly placing our building on top of the blueprint position, and we can continue with the generation of the roof point. To generate the roof, let's get all the points that we are creating for our last floor. Here, where we are filtering the floor attribute with the last floor threshold attribute calculated here, let's get these points from here inside the filter. Let's move a little bit here to the right, and let's do a transform points operator. Let's add a reroute node here to be a little bit more organized. So here I will generate the points for the roof. This is the points for our last floor, and after them here we can generate the points from the roof. Let's do again this split of the points with our subgraph, and let's start with placing the corners first. Let me move this view so I can show better here everything. So let's start with a transform points for our corners, and then static mesh spawner. And for this static mesh spawner, let's create a mesh entry, and into the descriptor let's connect our roof corner piece. So connect it here, and you can see that we started spawning the corner pieces. For all of the points that we are generating for the roof, we need to move them a little bit up. So I'll add 425 units into the Z direction, because the point for our floor here is at the base of the level for the last floor, and we need to move our points to match better with the placement of the roof. So let's move here the corner points, the X direction, minus 475, and to better align them, because now our roof is not aligned. So let's move the points to meet this corner better here. Let's select the transform points before copying, and let's move them 50 units to the side. Now it seems that it's centered fine. We need a little bit more movement in the Z direction. So let's do a 475, 500. Okay, 500 seems to do the trick. Great. So now we need to spawn the pieces for the walls and for the pillars. Currently our building is 3 units wide, so we don't need pillars here. Our corner pieces are covering this. So let's start first with the wall pieces. Let's spawn the mesh with a static mesh spawner. Let's create a mesh entry, and into the descriptor let's connect our regular roof piece. You will start to see that we have a problem. We are generating points for each wall, but for the last 2 walls that we have, the first one and the last one on each floor, we don't need this corner piece, because our roof corner is actually covering the whole area. So let's do a difference node before we spawn these meshes. Let's do a difference. Let's disconnect and connect it again after the difference. So for our difference node, let's do a bounce modifier for our corners. And this bounce modifier, let's click the D key to show where our corner points are. This bounce modifier needs to subtract the points from our regular roof pieces. So let's connect it to the difference node. And we need to adjust the size of these points in order to start removing the points from our roof. So let's select this bounce modifier, change the mode to translate, so it's easier to add values here with just scene values. So if we are using the scale, we need to use this as a multiplier, which is harder to imagine for me, but with the translate we just add units into the scene. So let's start adding additional bounds to these corner pieces. So let's start with this direction. If we add 400 into this direction, we are starting to better cover the size of our corner piece. Let's do minus 100 here, minus 200, minus 300. Let's do 100 here. Let's do minus 50. And I don't see an effect into our scene, so let's select the difference node and let's make sure that the density function is set to binary. And now I am properly getting the difference with this bounding box. So let's reduce now the bounding box until we can see the elements starting to appear for the middle walls. So here, let's start decreasing this to minus 200. Okay, now I can properly see this piece. This is extending a little bit too much, so let's try with 150. Okay, let's leave it like this for now. Minus 50, minus 150. Here, let's put 0. So we have more easy to deal with values. So now that we are properly differencing the result for our regular roof pieces, if I extend the building to a bigger size, you can see that we need fewer pieces between our regular roof pieces. Let's copy this static mesh spawner. Let's copy this difference because we will need it for the pillars as well. So connect the pillars to the difference, connect it to the static mesh spawner, and now for the descriptor here, let's connect the static mesh for these pillar pieces. So now we are spawning pillar pieces for each pillar of our building. Let's disable this node that's spawning the regular roof pieces with the E key so we can see better. Now we are getting again additional points over the corner piece here that we don't want. So let's connect this bounce modifier difference here. It is still leaving one of the pieces. So let's change the bounce modifier size here. Let's do a minus 200 in this direction. So now we get rid of the extra piece here. Let's enable the regular roof spawner. So now we are properly differencing the points for our pillar pieces for the roof and for our regular pieces for the roof. And we are spawning a corner piece for each of the corners. Now the only thing left for our roof to be finished, at least without the randomization of the elements, is to cover this hole at the top of the roof. So in the pack from the Quixel set for the Baroque building type 2, you have this horizontal piece, but we will need to spawn a lot of pieces and calculate a lot of positions for each of them if we are trying to use this as a generation method for this roof piece, and it seems a little bit excessive to me. So let's just create a single flat plane and scale it to the size of the roof gap here to cover everything, and we'll just apply a material that will imitate this roof material. So let's delete these pieces and let's go to the modeling mode to create the piece that we need. So if you don't have the modeling mode here, make sure that in your plugins, search for modeling and vote the modeling to editor mode and the static mesh editor modeling mode. You'll need to restart your engine if you are just marking them. And after you restart the engine, you'll have this modeling mode here. Click on the rectangle and generate a rectangle static mesh with the size of 400 by 400, let's say. If you click anywhere in the level, it will generate this mesh, and after you click the accept button, it will generate it in your maps folder on the current map, and it will create this static mesh piece. I already have it created, so I'll click the cancel, but you need to click the accept to generate this mesh. I'll click the cancel and I'll use this roof tutorial piece that I created. It's 400 by 400 units big. This is important for our calculations later. So now let's go back to our PCG graph. And in order to place this roof piece, let's get the point that we are creating for our last floor. So here where we are generating all the floors, let's drag out of this node. So remember here where we copied our points to the position of our blueprint. Then we filter them to only get the points over the position of the blueprint. We are getting all the points for the floors here and applying custom attribute named floor with the actual floor value inside. So let's drag out of here and let's do a name tree route declaration node. Let's rename this and name it floor points. So we can now use these floor points when we generate this roof horizontal piece. Right click and choose the 4 points name tree route. This name tree route is like we connected these nodes here all the way to the side here, but we are not getting crossing lines between all of our other nodes. So I like using name tree route nodes like this when we have the use of the calculated points very far away in the graph from the original value. So now we need to filter this node. We are already filtering the last floor filters here where we are generating the points for our last floor. So we need the same attribute filter that's checking if our last floor variable is equal to the height -1. So let's copy this filter. Let's paste it here. And let's connect our floor points here. If I debug now this node, I'll see all of our floor points. If I create a transform points after the filter, connect the inside filter points to these transform points and debug this. And now we have a single point for our last floor. With this single point, we will do a static mesh spawner again. And now for the mesh entries, we'll connect our generated piece. So connect this roof tutorial here. And now I just need to move it, the needed amount to be on top of the roof. So let's start adding here. Let's stop debugging. Let me scale this piece so it better fits the area of the roof. So let's try 2.5, 3. So now I can see that it's a little bit over the place where it needs to be. Let's move it a little bit down. Okay, 897. Okay, it seems that it's fine like this, 897 units high. And we need to calculate this scale min and max values in order to be changed each time that we change the size of the building by using this width and length variables, because if I have it statically set like right now, it's not changing and it's not covering properly the full hole on the roof. So how I can calculate this? When we are generating the floor, we are generating the grid with the size of this width and length variables multiplied by the size of a single wall plus a pillar. So we need the size of this wall plus a pillar value. So if you go back to the beginning of our PCG graph, this wall length and pillar length, if we combine it together, so drag out of this, right at, and now when we add both of these values together, we will do another name tree route declaration. We'll rename this and call it cell size. Let's save this. And now let's go back here into the area that we are generating our roof. So right click here, use this name tree route cell size, and we'll multiply the get actor property. We'll get the property of width from our blueprint, and let's copy this and get the property for the length of our building. So this one, length. Okay. So let's first do the calculation for the width, and we'll just copy it for the length. It will be exactly the same. So first, when we get the width, we have, for example, currently set to 7. So we have 7 wall and pillar pieces. So let's multiply this width variable by the size of our wall and pillar, which is our cell size. After we get this full value for the wall, we need to subtract the value that we are not using for the last 2 walls. So the corner wall here to the left and to the right, we don't need to include those into our roof piece because it's covered by this corner piece from the roof. So let's subtract this value. So do a subtract node, then create an attribute, connect it to the subtract. When we connect all the nodes, we'll enter this value, so it's easier to visually see here what it's doing. So for now, leave it at 0. After you calculate the full size that you want your roof patch to be, let's divide this by the size of the element that you created earlier. So let's copy this create attribute, and the size is 400 because I made the plane 400 units wide. So we need to divide by 400, and now we'll make a vector. This vector will be with 3 values. I'll copy everything here except for this width property and do the same calculation for this length property. I'll connect this to the Y value for our scaling, and I'll create another attribute for the Z value, which will be just 1 because we don't need any scale in the Z directions for our roof. So now that we have calculated the scaling of our roof piece, let's expand these transform points before spawning this roof element and connect this vector to the scale min and scale max. It will scale the roof and it will be too big. But for now you can see it's related exactly to these values that we set here. When I change the width value, the roof size is changing, but when I change the length value, nothing is happening. So when you select these transform points here, before spawning the roof element, these transform points needs to have this uniform scale checkbox set to false. Otherwise, it's using only the single value for the scale. If I uncheck it, and now let's save everything. If I change now the length to 5, now the roof is properly changing in both of the directions. The problem is that it's now currently extending over these edges. So we need to add the value that we left before at 0. Let's start adding a value here. 500, it's not enough. Okay, 1000. It's almost getting here. So 120, 1025. Okay, seems to be the proper value, 1025. Let's check the other direction. Let's add the same value because we have the same corner piece. So 1025. And now, if I change the size of our building to any combination of roof sizes, of width and length sizes for the building, the roof is properly covered on top. It's currently having this ugly gray material. We need to add the material for the roof. So let me first save everything and show you how we can do that. So if you go to the roof kit pieces, you have the material for the roof, but unfortunately the textures for this roof contain the texture for the side of the roof, for the top of the roof, for the corner piece, and everything else in between. So we cannot use this material. Fortunately, into your Quixel bridge scan, if you search for a worn painted metal roof, you will find this material. You can download this material, painted metal roof. It will look like this. And if we apply this material to our piece on the roof here, sorry, I can not apply it from here because it's inside the generated building. So let's open our roof piece, and here let's apply the material to our roof piece. The problem with it is that when we are scaling this piece, it's getting the single texture size for the full piece, and we actually need to repeat it a lot of times. So to fix this problem and not recalculate every time how much times we need to multiply this texture, we'll do what's called world align texture. So let's create a new material here into our generated roof piece. So let's right click and create a material. I'll call it material world aligned roof, for example. And inside this material, let's open it. Let me first apply this material to my piece. Let's save this and close it. So now I have this material created. Let's get the textures here. So drag this texture sample. And now let's create a world align texture. So let me expand here this a bit to have more room. So drag out of the texture and do a world aligned texture. So this world aligned texture will get this texture object. So I cannot connect this texture to this node. So let's delete this node and instead of this create a texture object. This texture object needs to have this texture connected to it. So drag this texture over this object. And now you can connect it properly to this world align texture node. You need to set the size and the position of the node. So for the size, we'll just create a vector with the 3 values. So hold the 3 key and click anywhere. And this will connect a vector with 3 values. Let's connect this to the size. Let's for now enter 111 on each of these values. So to determine the world position, right click somewhere and type absolute world position, or let's write on world position, and this will give you this absolute world position field. So this drag out of this XYZ coordinate, connect to the world position, and now if you use this world align texture node and connect it to the base color of our element, let's apply and save this material. It will take a little time to generate. Now you can start to see that we are getting this color. The size is too small, so let's increase this to 100 by 100. Let's apply this. Now you're starting to see that we are getting this material closer to what we need. The size is still a little bit too small, so let's change this. When I tested, the 325 value seems to do okay. So let's apply this to the material. Now, this is a closer size to what we need for our roof. Let's save this for now. And we need to also connect the texture for the roughness and for the normal map to have this material look closer to our roof. So let's do 2 other texture objects. So create a texture object, create another texture object, and let's connect these 2 textures to it. So first let's connect this one which contains the roughness in the green spot, and then this one which contains the normal map. So copy this world aligned texture node 2 times, connect these nodes to the corresponding texture. Now connect the world position to all of them and the size that we are setting again to all of them. We can use this normal directly here to the normal field, and for the roughness we just need the Z value. So let's break the vector for our roughness texture. The roughness is contained into the green value, so let's connect the green slot here into the roughness. Let's apply now all the changes to our material, and now we are properly getting the same type of material for the roof of our building. Let's save this material. And let's continue with the generation of elements to our building. Let's say that we want a little bit of more control over the look of our roof. Let's close this material for now, and let's go back to our PCG graph. So when we are creating our roof, we place this single type of mesh on every wall of our last floor. So let's add a little bit of randomization by opening this static mesh spawner and adding another mesh entry, which will connect to this other roof piece into the pack. That way you're getting some elements with this chimney and the other without. You can probably set the weight of this second element a little bit lower. So let's do a 0.5. So we have a lot more elements without this chimney. We don't get any right now, so let's increase the weight to have it as a whole number, I guess. So let's change the weight here to 1. And for the other one, let's change the weight to 2. So we have more of the regular piece and less with the piece with this chimney. But still, we are getting a little bit of randomization for the elements. You can also set up roof windows placement with the same logic that we used to create the repetition of elements on the first floor. For example, these doors and the repetition of the windows of the next floors. Like we have currently double and a single window on each floor. So to do this, you need to create a new variable inside the blueprint. So open the blueprint, click on the plus variable sign, and make a roof window repetition variable. Let's copy this name. Let's make this an integer and let's make it public in order to be able to be used into the PCG graph. Go inside the PCG graph, and first let me show you something, because the generation of the roof that I showed you now is using, let's go back to 3x3. So the generation of the building is using this offset of 50 units for the roof currently. So if I remove this offset, let's make it 0. Now, don't change anything in your script. This is just a demonstration. The roof is too low now, so let's increase the height. Let's say now the roof, we also need to move it into the other direction. So now the roof is properly centered on this corner piece. So the problem, if you don't use this offset, is that when you have your roof pieces, you cannot fit a full roof piece right here. So if I rotate this piece 90 degrees, if I place it here, you can see that it's extending outside the roof. So it is really hard to do the repetition of the roof properly if you don't set up this offset like I showed you before. I have the PCG asset tested previously, and I have created this repetition without the offset like I showed you now, but it's really hard. You can see it involves a lot of conditional nodes and placement of a lot of smaller meshes to fill in this gap. It's different based on the width and the length, which one is smaller than 3 and so on. So I believe the way that I showed you in this video is much simpler and much better, but it will require one change for the roof window, because the roof window, let me go back to the building. Here is the default roof window, like it's coming from the Quixel pack, and it requires you to not have this offset into the roof. And I have created another piece which has this offset in order for you to create the building with the easier PCG script. And this custom piece will allow you to do this without all of the unnecessary logic that it's required to do it with this type of roof that's not properly connected to the building. I believe that this is a much better approach. I will leave a link into the description to download this object. Like every other object from Quixel, make sure you're using it inside the Unreal Engine, or you have a valid license to use it outside. So I'll be including this just for educational purposes. For you, make sure that you're following the proper guidelines for using the object. So let's go back and return the roof generation like it was before. So here I had minus 475 and I had a 50 offset here and 500 offset here. So now I'm properly filling in the roof with a single piece when we have a width or length of 3 units. And instead of placing this regular roof piece, so let's enable and disable to show you the piece that we are spawning with this mesh spawner. Let's copy this mesh spawner. Let's select the top one. Let's remove this additional piece like that we set up for the randomization. So delete this. And into the first one for the static mesh, into the descriptor, let's place this custom piece that I made. Let me connect it here. So now, instead of spawning the regular roof, we are spawning this wall roof piece. So let's create the same logic like we had with the repetition variables. So copy the modulo, the filter, the subtract, and the one value, everything except the actual actor property that you use for the repetition. So copy this from the setup of the first 4, for example, and paste it here when we are placing the values for the roof. So connect the points into the modulo operator. Inside the filter we will be spawning the roof window, and outside the filter we will be spawning the regular piece. And here we need to get the actor property, and the property name should be the one that we set up into our blueprint. So roof window repetition property. Go back here, property name, and connect it to the modulo and the subtract operator. Let's save everything. Let's select this blueprint. And let's set this roof window repetition to 0. That way we are spawning only outside this filter, the regular roof. If I change this, the roof window repetition to 1, every time when we are placing a roof over a wall, it will be this roof window. And you can see it's placed over the roof. So we need to translate the points before we are spawning the mesh. So transform points. These transform points, let's move them minus 400, I believe, will be fine. Let's connect. It's not enough, so minus 425. Now you can see that we are properly connecting the roof to the other pieces. And the problem we have is that it's overlapping the wall from the last floor. So here, let's save these points that we are generating for this roof piece. After this transform point, drag out and choose name tree route node. Let's rename this and call it roof windows. And let's go back here into the placement of the points for the last floor. So here, when we are placing the walls, so select this node and hit the E key to check. When you disable it, all the walls should disappear. So instead of spawning directly these meshes, let's do a difference node. And let's choose this name tree route that we created, the roof windows, and add this to the difference pin. So now let's disconnect these walls from the static mesh spawner and connect these difference nodes. So now if I disable this roof window spawning, you can see that this difference node is making sure that we are not placing walls where we will have this roof window. So if I have the roof window repetition set to 0, I don't have roof windows anywhere, so I'm placing the last 4 elements everywhere. If I have it to 1, so everywhere where I will be placing a roof window, I am not going to have the last 4 window. So let's change the width to 5. You can see if I enable now the roof window placement, I'm having properly connecting meshes everywhere. So let's change the roof window repetition to 2. Now everywhere where I don't have it, I have a wall on the 4th floor, and everywhere where I will have it, I will not place a wall below, so it's not overlapping. This will be everything for the roof setup. Now let's continue with placing the windows inside these frames for each floor. So let's get the points that we are generating to place everywhere a window. So for example, from our last floor, here we are placing onto these points windows. So let's drag out of here, do a transform points. Let's move this on some new part of the graph. So this will be our last floor windows. Let's do a static mesh spawner. And let's spawn a mesh with the glass material. You can find any glass material onto the Quixel Megascans, or just create your own and create another element that's 400 bar 400 units, for example, and assign this glass material to it and use it inside this mesh spawner. So you can duplicate the element that we created before for the roof, just assign another material to it and spawn with this static mesh spawner this plane. So now I'll use these transform points to rotate x-axis. Okay, now when I rotate into the x-axis 90 degrees, I'm covering the entire wall with this glass material. So let me move it a little bit back. Let's move it 25 units back, and now I have a window into each frame for the last floor. 25 it's too much. Let me have it as 20. Okay, now it's better fitting this frame. So let's continue with the middle floors. So every other floor, it's spawned here. Some of these walls, for example, the ones that are with the one window are spawned here, the ones with the two windows are spawned here. So let me do transform points from each of them. Let me move them here to have everything for the windows at the same place. Let's connect everything to this spawner. Let's rotate again 90 into X. Let's move them 15 units back. For these walls, 15 units seems okay. Let's check the other ones with the single window. Let's rotate again 90 degrees. And let's move back 20 units. 20 is too much. 15 is okay for this as well, so I can use the same transform points for both of these. Let's connect, oops, sorry. Let's connect both of them to the same transform points. So this is generating all the windows for the middle floors. This one, all the windows for the last floor. Here I have a problem where my window is overlapping these doors. So I need to not be placing windows over this. These are probably the windows from the bottom floor. So let me scale the windows a bit down here for the bottom floor. So let's scale by 0.5, 0.4, 0.3, and they are now too little. Let's say 0.4, and let's move them a little bit to the side and up. Okay, so now I have the windows properly covering each frame. For the last floor, maybe I can scale them as well. 0.6. So we are sure they are not overlapping anything else. And what I have to do now is just spawn for the doors some windows again. So here is our first floor. Let's start disabling each node to check where we are placing the doors. We are placing the doors here into this static mesh spawner. Let's go out of this spawner, do a transform points. And from these transform points, let's spawn a window. Let's rotate it 90 degrees. Let's move it 10 units back. 15 maybe. 15 is too much, it's behind the door. I can move it 7 units back. Okay, now it's better matching the door. Let's scale it a bit down, like we did for the top windows. Let's move it. Okay, now it's covering the door better. If I disable the door, you can see the window. So you are now getting windows on each door and each other window on the upper floors. So the last thing that we have to do to make this building look more realistic is add some decals. When we are placing our windows for the middle floors, let's say, we have them placed here. So instead of the windows, let's use the pillars, because for the windows we have a couple of different nodes, but the pillars are always spawned from this node. So let's drag out of this static mesh spawner, add a name tree route, and rename this node and call it for middle four pillars. And this middle four pillars go some other place on the graph, let's say here next to the windows. Let's right click and choose this middle four pillars. And instead of using a static mesh spawner, let's use this spawn actor node. So this spawn actor can spawn for you a decal by choosing here the template actor class to be a decal actor. Then here, instead of collapse actors, choose no merging, and now you are able to change the template for your decal actor, because before you are not able to click this allow template actor edit. If you choose the no merging, you are now able to mark it, and inside this decal drop down you can set a decal material here. So go and download some decals from the Quixel Megascans store. I have this leakage decal, for example. Let's connect this here. Let's choose some other one to be better visible to our window. So now I have this leaking decal. I'm spawning it everywhere that I have this pillar. So let's do an attribute noise. Let's set the density from 0 to 1 inside this node noise, and then do a density filter. So let's filter everywhere where we have a density between 0.6 and 1, for example, and only then spawn this decal actor. This will give you a little bit more random view. You will not spawn everywhere this actor. Before spawning the actor, let's do a transform points. Let's use these transform points to move this decal. Let's go into the spawn actor and fix the size of the decal. So open the decal unit. Let's change the size. So let's change the vertical size with 128, and let's change the depth to 10 units. That way it's not so big that overlapping everything like the windows. So now if I select some of the decals, you can see they are rotated horizontally. We need to rotate them vertically. So let's select these transform points and rotate the x-axis 90 degrees. And now you are properly seeing this decal, like some water is, or some dirt is applied to the wall. Let's move this below the window. So using these transform points, go into the offset min and max and add 200 units, which is half of our wall size. Let's add a little bit more, 225, to center it a little bit better. Let's move it down a bit. So now let's scale this a little bit smaller. The problem when you scale this decal is that it scales from the center, and we want it to scale from the top. So we can place it below the windows and have a random size. So let's go back here into the spawn actor. Let's go open the decal template class, and here into the transform, let's add a relative transform, the Y transform, minus 228. Now if I select this, it's properly placed next to the wall. Okay. Let's use the transform points to place it better now. Let's move it 250 and let's do a minus 100, no, minus 75. Okay, now it's better applied here. I'm not sure how good you are seeing this over the YouTube compression. Let's change something to make it a little bit better to see. So let's open this decal material, how it will be easier to see. Let's change the opacity. So I'll change the opacity to 1. Let's save this, and now it will be a little bit easier to place this decal properly. So now with the transform points, move it a little bit up, minus 70. You can change the depth here to affect the front of this if you want. Let's extend the depth to 20. So now it's affecting here the front brick as well. Let's move it a little bit more up, minus 65. Minus 67. Okay, now it's properly placed here, just at the line where our windows are. So we are now having this placed at the bottom of our windows. You can spawn other type decals. For example, let's do another density filter. Let's do from 0.2 to 0.4. Let's do a transform points and spawn some other leakage. Let's open the decal and put this other material. Let's open this material. Let's change the opacity to 1. Now let's place it better. For example, we'll be changing the size from 0.2 to 0.5. Then go back to the opacity, put it at 0.5. Let's save this. Let's put the other one at 0.5 as well. So now, if I hit the G key to hide the billboards that are showing where we have decals. So with the G key you can show and hide where you have additional elements. You can see that some of our windows have this leakage and some not. So probably it's not the best decal for this building because it's a little bit too wide for this single windows, but you get the point. You can choose another decal if you want. Let's say for the first floor, here when we are spawning our walls for the first floor, where we have it, this is our middle floor, this is our last floor. So here we have the walls for our first floor. So from the pillars, let's do a density filter. Actually, first attribute noise. Let's choose the density as the attribute that we want to add the noise to. Then density filter. Let's say 0.3 to 0.5. And we'll transform points first. And we'll spawn an actor, which will be with no merging of a decal actor type, and we'll allow the template override. The decal material will be some graffiti element. Let's say this one. So now let's use this transform point to move it up. Let's reduce the vertical size of this decal. Go into the decal size. Here for the first one at 10. Here 128. And we need to rotate this decal. And you can add random translation, for example, in one of the axes, so -100 to 100. Let's choose the other axis, -100 to 100. Let's add some random rotation, -10 to 20. Let's add a random scale, 0.5 to 1. So now you have somewhere this. Let's randomize the vertical position as well. So you have somewhere this graffiti objects only on the first floor because we use the points for the first floor. Let's increase the density filter to have more of them to see the randomization. Now you can see the random size, the random position, random rotation. You can change any of the values here. The important thing is that in this way you can choose which points you can use to generate the decals for, and every time you generate a building it will generate you a random set of decals as well to have different type of additional detail to your buildings. So this is everything that we have for the setup of the PCG building. In another tutorial I can show you how you can quickly change the appearance of this blueprint by adding another set of elements from another pack from Quixel. So you have a completely different building generated with the same type of logic that you have for this one. So hopefully you liked it. If you have any problems or some questions, please write in the comments. If you like the video, like and subscribe to the channel, and I'll see you in the next one. Bye.